All right, so here we go. We're going to take a look at the constructed response questions for Module 2. So this is something you should go over if you've already completed them, right? Use this time to check your answers here. And if you have questions, make sure to reach out after this video here. All right, so for the first one here, it says, listed below are the grades in class received on a practice driving test. So if we're taking a look here, if we take a look, we have 16 grades and they range from 70 all the way up to 92. So 70 up to 92. So which representation would be the best to organize the driving test scores? A dot plot, a histogram, or a box plot? So when we have less than 20 data points here, right? A dot plot is usually a pretty good way to show this data, especially because our data isn't too spread out here. So if we're going through here, I would say a dot plot. And that's because there's a small amount of data. And it is not very spread out. Too far. All right, so now it says draw the representation you chose in part A and to organize the driving test scores. So if you did choose a different one, all right, you can still go through and draw your different representation here, but I'm going to draw my dot plot here. So dot plot always starts with a line. So I'm going to start by drawing a line. Let's see if we can make this as straight as we can be here. And then if we're going through here, right, I said we have numbers from 70 all the way up to 92. So I'm going to start it with 70, then we'll count, right? So 71, 2, 3, 4, 5. So this is 75, 76, 7, 8, 9, 80. And then keep going here. 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, then 91, 92, 93, 94, 95. All right, so this goes all the way up to 95 here. I guess we don't need this second part of the slide here, but that's fine. All right, so now we're just gonna put the dots onto the plot here. So the first one is at 75. We put a dot for our first data point there. Then 78. So if here's 75, then we have 76, 77, 78. Put a data point. 83. So if we're here at 80, I'm going to make these ones a little bit bigger. 81, 2, 3, 4, make 85 a little bit bigger. 90 a little bit bigger so they're easy to see. 83, 1, 2, 3, put a data point. 75, another one. Then we have it 90, 85, 70, 92, 88, 78, 80, 83 again, 83 a third time, 80 a second time, 90 a second time, and 85 a second time. So there's all our data points there. If we take a look, it says describe how the median and the mode of this data compare. Well, the median, we take a look here, we're going to have to find the median. So there's two ways to calculate the median. The first way would be to write out all of these numbers in order, right, and find the middle number. So we can do it that way first because, again, remember, we only have 16 pieces of data. So our first number is 70. Then we have two 75, so 75, 75. Then we have 78, where we have two, so 78, 78, 80, that we have 2 points at, so 80, 80. Then 83, that we have 3 at, 83, 83, 85, which there's 2 at, 85, 85. Then here we have 88, 90, we have 2 points at, and the last one, 92. So to find the median, we can go through, right, and kind of cross off one from each end until we get to the middle. So we have cross off those two. and keep going until we're left with one or two numbers, depending on if we have an odd or even number set of data. So we have an even number, so we should be left with two numbers, which will be 83 and 83. And we want to find the number in between. Now, they're the same number, there's no number in between. So the median here is 83. So our median is 83. Now, another way we could have done that is that same method of elimination, but we could have used our chart here. All right, so we could have crossed off one at the beginning, one at the end, and then keep going through until we got to our middle. So we keep going. And we would have seen that we were left with these two, which were both at 83 again, right? And then we could say that it would be right in between there at 83. All right, so the median's 83. And then we need to find the mode. The mode for this data is the number that happens the most. Well, we can do that either by looking at our list of data here or by looking at our chart and see that the mode is also 83. So it says here to describe how the median and the mode compare. They are equal, right? And then our explanation can just be showing the work there to find both of those. So the median and mode for this data were equal. All right, so that's the end of question 1. So we can flip over to question 2. Let's zoom. All right, so let's go over to the next question. So question 2. So question 2 gives us a scatter plot. It says it shows the result of the study of effects of exercise on the resting heart rate, and it wants us to start by drawing a line of best fit for this scatter plot. So it doesn't ask us to calculate the line of best fit, right? And since we have so many data points that we don't know exactly where they are, we're just going to do our best to draw a line. So my line is actually going to go through two set points here. The first one, I'm going to start right at 72 and 0, or sorry, 0 and 72. And then I'm going to keep going through all the way until I hit this last point here, which is at 20 and 64. So that is the line of best fit that I have. Right? It has a decent amount of the numbers of data above and below, right? Because we wanted to cut through our dots there, not connect them all, but cut through our dots and have the same amount above and below our line of best fit. So for that sketch there, I would recommend you do it the same exact way through 0, 72, and 20 and 64, because that will help us when we have to calculate the equation of the line. So if we move on to part B here, it says write the approximate equation for the line of best fit. Well, remember our equation for a line is y equals mx plus b, with our y being our slope and our b being our y-intercept. Well, right away, looking at this line here, right, we have our y-intercept, and our y-intercept is right here, which is at the point 0, 72. So right away, we know that our b is equal to 72, and we just have to find our slope. So if I use that point, 0, 72, and then this point here, which is 20, 64, we can use our formula to find slope. So remember, slope is equal to y2 minus y1 over x2 minus x1. So in this case, m is equal to, we take this as our second point here, so this will be our y2, which is 64, minus our y1, which is 72, divided by our x2, which is 20, minus our y2, or sorry, our x1, which is 0. This is going to equal to negative 8 over 20, which equals negative 0.4. So our slope will equal negative 0.4. So now if we need to write our equation for a line, we're just going to substitute in our slope and our y-intercept, and it will give us our line of best fit. So y equals negative 0.4 x plus 72. So this here is our line of best fit for this set of data here. And then we're going to use this in C. So C says to use your equation to predict the resting heart rate of a person whose exercises 30 minutes per day. So 30 minutes per day, if we take a look up at our graph here, the exercise minutes per day are X values, while the resting heart rate are our Y values. So we need to predict the Y. So we're going to find the Y when they exercise 30 minutes per day when X is equal to 30. So we take our equation, Y equals negative 0.4X plus 72. And we're just going to substitute in 30 for X and then simplify it here. So Y equals negative 0.4. Then instead of X, we're going to substitute in 30 minutes plus 72. And if you were to work this on your calculator, right, you'd see that negative 0.4 times 30 is negative 12 plus 72. And then negative 12 plus 72 is equal to 60. So the resting heart rate of a person who exercises about 30 minutes per day is 60 beats per minute. All right. Now it says here to use your calculator to find the correlation coefficient, which best describes the data in the scatter plot. I'm going to tell you that I wouldn't expect you to go through and put in all these sets of data. We are going to do that in one of the later questions. So what I'm going to do is just give you the suggested answer here that they found when they worked it out here. And they found that the correlation coefficient, which remember is R, when we run our linear regression, was about negative 0.96. So negative 0.96. So then they want you to explain what R means in terms of this given data. So when we see a negative number here, right, it shows that there's a negative relationship. And then when it's negative 0.96, it's really close to negative 1, which means that there is a strong negative linear relationship. All right, so there's a strong relationship as one variable, as the X variable increases, our Y is decreasing. And if we take a look up here, you can tell it's really strong because all of those data points are really close to our line of best fit, and it is a negative slope because it is decreasing as X increases. All right, so that's the end of question 2. So now we're going to jump over to question 3. So question 3 has to do with a bunch of seniors and juniors and how they get to school. So Gerard surveyed 75 juniors and 75 seniors at his school about how they typically get to school each day. The results of the survey are shown in the two-way table below. A, complete this two-way table by filling in the missing frequencies in each empty cell. So if we remember here, when we have this table here, right, each row represents a certain set of data that has its own totals. And then each column also represents a certain set of data. So these here, so the juniors and how they get to school is that first row. Seniors and how they get to school is the second row. And then our totals is the final row there. Then if we're looking at our columns here, right, so if we were to choose a different color, the first column just represents people who takes a car. Second column represents people who walk to school, and third column represents those who take the bus, with the fourth column being the totals of all students that were surveyed. So I'm going to erase that there, and we can fill in the data here based on our totals and what we're given. So if there is any row or column where we have 2 of the 3 pieces of data, or if we're looking at the rows, 3 out of the 4 pieces of data, we can fill in the missing one. So our first piece that we can fill in that's missing is our juniors here. So the way that we fill that in is we need to find out what number, when we add it to 15 and 40, will give us 75, right? So if I was using my calculator, I'd take 75 minus 40, all right, and that would give us 35 minus 15, and that will give us 20. So to find now, when we look at the seniors, this row here, we can't fill in these 2 by looking at the row, right? Because we don't have both of, we need to have one of these to be able to find the missing one. So what we're going to do now is switch over to columns here. So the first column here, this just wants our total. 20 plus 48 is 68. Now, the second column gave us 15, which is the juniors that walk to school, and it gave us the total students that walk to school, which was 22. So if we want to find out how many seniors we need, we just need to subtract 15 from 22, and we get 7. Now, when we take a look here, if we're looking at the column here, we don't know how many seniors there are, so we can't add it up to find a total. So now we're going to go back to our rows. Well, we see for seniors in this row, all right, there are 75 total. So if we want to find what's missing here, we're going to subtract 48 and 7 from 75. All right, so 48 and 7, if we add these together, we'll get that that's 55. 55 minus 70, or 75 minus 55 is 20. And now to get our total down here for those that take a bus, we can just add those 40 plus 20 together and get 60. Double check this last section here. So 68 plus 22 is 90, plus 60 equals 150. So we're good. So now we've completed this two-way table. B says, what is the relative frequency of juniors and seniors who take a bus to school? So relative frequency, so we're looking for the total number of juniors and seniors that take a bus relative to the total number of juniors and seniors. So those that take a bus, if we take a look up here, the total numbers of juniors and seniors to take a bus are 60, right? Which is this piece of data here. And then the total number of juniors and seniors that we have in the school is 150. So we have 60 over 150, which if we simplify this will give us 0.4. So that's where we can find our relative frequency of juniors and seniors who take the bus to school. Then C says, what is the row conditional frequency of juniors who take a car to school? So row conditional means that we're just looking at this row here. So we're just looking at juniors, and we want to know juniors who take a car to school. So we're going to highlight the total number of juniors who take a car. And then if we're just looking at this row, the total we're going to use is the total number of juniors that we have, which is 75. So juniors that take a car is 20 over the total number of juniors, which is 75. Then this works out to be approximately 0.267 when we round here. So about 26.7% of juniors take a car to school, which isn't a whole lot when we say that there's 3 different types of transportation, right? Because it's less than 1/3. So now, the final part here says, what is one conclusion you can make about how juniors and seniors get to school? So this one, you could have lots of different answers here as long as you can back it up with your data here. What I'm going to say is that the majority of juniors take the bus, and then the majority of seniors drive a car. So these are 2 statements that I can make, but now I want to back them up with data. So if I'm looking at juniors and how they get to school, right, I'm going to look at the row conditional frequency here. So the row conditional frequency for juniors that take the bus would be 40, then over 75. So 40 over the total number of juniors, which is 75. This works out to be 5.3, or sorry, works out to be 0.533, and then this kind of repeats on, so we can just round it there, which is about 53% of juniors take the bus. So that's more than half, so that's the majority. Then, to show the majority of seniors drive a car, I want to take the row frequency, row conditional frequency of seniors, so the total seniors that take a car, over the total number of seniors, which is 75. So the total seniors that take a car is 48 over 75, and then that equals 0.64, which shows that about 64% of seniors take or drive their own car or drive a car to school, which is the majority there. So that's one conclusion that I made based on this table. There's other conclusions that could be made, right? If you're talking about that most don't say do something, you can prove that with the data also on that table. All right. So now moving on to question 4. So question 4 has to take a look at dot plots and box plot. So the dot plot below shows the points scored by the Lions in each game they played this year. And the box plot below shows the points scored by the Hawks in each game played this year. So which team has a greater number of median points, the Lions or the Hawks? And then show or explain how you know. So if we're going to do this here, we got to first find the median for each of these teams here. So if I take a look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data for the Lions. Now, the reason we need to know how many pieces we have here is if we're going to find the middle or the median, we need to be able to know which number the median falls after. So if I want to find the median and I find the total number of pieces of data to be 15, if I want to find the middle number, what I can do is divide this by 2 and find that I get 7.5. What that means is that 7.5 would be right in the middle of 15. So if we want to find the number that's in the middle, there's going to be 7 numbers before and 7 numbers after our median there. So if I wanted to find the median, I'd start and count to find the 7th piece of data. So we have 1, 2, 3, 4, 5, 6, 7. And then the 8th piece of data, right, is our median. So the median here is 50. So for the Lions, our median equals 50. Now for the Hawks, if we want to find the median, it's a little bit easier because we have our box plot here. The median is just the middle number, and it's represented by this middle line here in the middle of our box here. So if we go down, we can see that this median is actually 44. So the Hawks, the median is 44. So which one has a greater median? The Lions have a greater median. Now, which of these two teams has a greater interquartile range? So the IQR, remember, is the 3rd quartile minus the 1st quartile here. So if we take a look here, for the Hawks, the interquartile range is going to be 56, which is the 3rd quartile, minus 36, which is the 1st quartile. So 56 minus 36, which is 20. So this is a pretty big range here. Now for the Lions, it becomes a little bit more difficult because so far we have the median, right? But we don't have the 3rd quartile. So now if we're looking at our set of data, we have these 7 dots down here below the median, or to the right of the median, right? So let's actually erase this one line here. So we have these 7 dots, 1, 2, 3, 4, 5, 6, 7, that are in the top third, or top half of our data. And then we have these 7 dots to the left that are in the bottom half. So we want to find the middle of each of these sets of data here. So if I was to find the middle and I have 7, right, I'm looking for the 4th piece of data here. So if I start at the left, we count 1, 2, 3, 4. So this is going to be our 1st quartile. And then do the same thing from the median here. So 1, 2, 3, 4. So this is going to be our 3rd quartile. So here we take the 3rd quartile, which is 52, and we subtract from it the 1st quartile, which is at 44, which gives us a range of 8. So it says, which of these two teams has a greater interquartile range? It's the Hawks with an IQR of 20. All right, now another way that you could go about this, if it's confusing with the median here and finding the 3rd and 1st quartile, is you could list out these pieces of data here and then create a box plot from this data, right? So if we're looking here, we could list this out as like 38, 38. Then we have 42, 3 42s. Then a 43. Or sorry, we're counting by. Oh, sorry. These are 44s. My apologies, right? Because we're counting by 2. And then 46. Then we have 1, 2, 3, 4 50s. Then two 52s and 3 58s. So you could go through then, and if you wanted to find, right, your median, right, we can go through and like cross off one, and go through this way. And we'd see that the median here was 50, right? So this was our median. And then if we wanted to find the first quartile, we would take our first half of data and find the median here. And we would see that it's here at 44, right? And then if we did the same with our second half of data, and we found the median, we would see that it's 52 here. And that's where we can find those numbers that we found down here. All right. Looking at question C, says the Lions and the Hawks will each play one more game this year. Which of these two teams is more likely to score more points in this game? Justify your answer. Well, if we take a look here at the data for the Hawks is a lot more spread out, right? So they're scoring a wide range of points. Well, if we look at the Lions, most of their points are grouped around their median there. So because they have a smaller interquartile range and their median is higher, I'm going to go ahead and say the Lions will score more because they have a higher median and smaller interquartile range. All right, so that's the end of question 5. So now we're going to move over to question 6. All right. Sorry, that's the end of question 4. Now we move over to question 5. All right, so this one says the scatter plot below shows the age and length of 20 alligators. Draw the line of best fit for the plot above. So again, we're going to draw a line of best fit. We're just going to estimate it here. Again, I'm going to start at an easy number to work with, which is going to be right here at 0, 10. So my line will start at 0, 10, and then I'm going to keep extending it all the way till I hit here at 1070. So that gives me 2 points that I can work with, right? So 0, 10, and 1070, which I'll be able to use for part B, which is write the equation that best describes this line of best fit. So we have our y equals mx plus b, right? With our y-intercept, looking at our graph here, it's 10 because that's the y value where x is 0. And to find our slope, we're going to take our first point and our second point and put them into the equation y2 minus y1 over x2 minus x1. So here we have m equal to y2, which is 70, minus y1, which is 10, over x2, which is 10, minus x1, which is 0. So then our slope equals 70 minus 10, which is 60 over 10, or 6. So now we know our slope is 6, so we can write our equation, y equals 6x plus 10. And we wrote that just by substituting in our slope and our y-intercept into the equation y equals mx plus b. And now if we continue down here, explain the meaning of the slope of this line in this situation. So whenever we're explaining the meaning of slope, one formula we can use here, or sentence frame we can use, is we could say as blank, which is our x, increases, then we could say blank, which are our y values, and then we say what they do. So as age increases, and we can even say how much it increases by. So as age increases, let's just erase this part. As age increases by 1, right? So this is the m. Then the blank, which is our y, right? Or sorry, increases by 1, which is, it's not the m, but the rate, because we found this rate here. Then the length, and then in this case, increases by 6 inches. So as we go over 1 year, we also get 6 inches longer in general, based on this data. So explain whether or not the data suggests that increasing age causes the length of the alligator to increase. So this is something that we looked at here with causation. Causation, right, is hard to tell from a set of data there. So this does not show causation. So we can say, while there is a strong relationship, a strong positive relationship, the increase of age cannot be proven, right, to cause an increase in length, So again, we have a really strong relationship there, but we can't show that one is causing the other to increase. We can't prove it. So there is no causation. All right, so now let's go on to the last question here, question 6. So this one, we are going to use the calculator because we're given only 10 pieces of data. And so this one won't be too bad to put in there. Plus, we're going to use this to create a residual plot. So it says that Larissa recorded noon temperature at her house during the past 10 days. She plotted the data on the scatter plot below as shown. So if we want to go through, it says, what is the equation of the linear regression that fits this line? Use your calculator to find the equation. Well, in order to find the equation, we first want to have a table of data here. So what we're going to do is we'll have the days up here, right, which are x values, and then we have the temp, which are our y's. So we can start with the days. We know we're going all the way up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I guess we don't need this part of our table here. And now we're going to fill in the temperatures. So I'm just going to kind of make this table fit in a little bit here. All right, so on day 1, in between 38 and 40 is going to be 39. Day 2, we're up to 50. Day 3 and 4, we're at 54. Day 5 is up to 55 degrees. Day 6, we jump up all the way up to 60. Day 7 is up to 57 degrees. Day 8, we're at 48 degrees, so big drop there. Day 9, big drop again down to 43 degrees. And day 10 is at 40 degrees. So now what we're going to do is use this, we'll input this data table into our calculator, and so that we can get a linear regression. So let's switch up our share a little bit over here. So instead of that share, let's do a screen. All right, so now what we're going to do is add our list and spreadsheet. So we go down to choice 4, add list and spreadsheets. When we add our list and spreadsheet, we need to first label the first column, which will be our x values or the days. And then B will be our second column, which will be the temperatures. So we'll go through and start inputting our days. So the days, right, are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then our temperatures, right, on the y value. So the first one is 39. Then we have 50, 54, 54, 55, 60, 57, 48, 43, and 40. So now what we want to do is write the equation of this line by calculating a one variable statistic. So we go up to cell C1 so that we can input our information here. Then we click on menu. Then we're going to do statistics, stat calculation, and then linear regression, mx plus b. For our x list, we want to choose the days, which is our x value. The y list, our temperatures, which are the y value. Then we hit OK, and we get our linear regression here. So if we take a look here, the linear regression has the slope, which is negative 0.339, and our y-intercept b, which is 51.867 there. So if we go through, and it says to write our equation, we'll have y equals, then our slope, which was negative 0.339x, plus the y-intercept, which was 57.867. So now it wants us to go through and use our calculator to create a residual plot that models the relationship between the linear regression line and the residuals. So if we go through and we create this plot here, right, we'll go back to our calculator. Now we want to add a new page here, right? So we can do control, document, and we want to add a data or statistics. So when we're here, right, now we need to figure out what to put on our different axes here. So on the x-axis, we want the days, right? Because we want to see relative to the day where things are. Now we should see a point at each day. So now if we want to do a residual plot on the y-axis, we take a look and we're looking for stat residual. We can see the residuals for our linear plot there. So if you take a look here, we have our different residuals and how they're plotted across this time here. So if we wanted to go through here and copy this onto your table here or onto your paper there, this is what you'd want to copy. So let's see if I can just, for my sake here, I'm going to, we'll just snip this here. Well, so we don't want to do anything there. Snip. I'll snip this, copy this, and paste it in on my table here. So you can do yours a little bit differently, but I'm just going to take, copy, and paste. So I'll take my plot here and just put it down there so that you can see. So if we take a look here, see how our residuals are going in kind of a parabola shape here, right? So this isn't good because remember with residuals, we wanted to have them scattered above and below, right, in a somewhat random pattern. This, however, looks like it has some sort of pattern, and it's not above and below, it's below, then above, and then below. So what does the residual plot say about the linear regression line for this data? It says that it's not a good fit. So the residual plot says the linear regression line is not a good fit for this data. All right, so when we're looking here, it shows that it's not a good fit, right? We want it to be randomly scattered close to the line, and this is not that. All right, so that is the end of this lesson here. All right, so this is the end of the review. So if you want to go through, if you have questions, make sure to reach out. Other than that, get ready for the next module, which will be module 3.